Hello. What we're doing today is we're trying to design an electronic circuit that uses an inverting comparator circuit with positive feedback to provide hysteresis. And this circuit is being designed so that it has a high threshold of 1.5 volts and a low threshold of 1 volt. The circuit uses a precision bandgap reference to try to get the switching thresholds as accurate as possible. This signal generator here is the signal input. I have a ramp wave from going between -10 volts and 10 volts as my test input. This is the comparator with the positive feedback resistor and the input resistor. This is the precision bandgap here, which is 2.5 volts. This is a potential divider to scale the bandgap voltage down, and this is a unity gain op-amp. Okay, so I'm going to use the tool, the DOS tool, to try to calculate the resistor values using values from the preferred resistor sets. So for these two resistors I'm going to use values from the E24 series resistor set. Okay, so let's start the tool going. So define resistors to use, option 3. I want to use the E24 series. Then I want to go to inverting voltage comparator, because that's what we're doing, which is option 13. So now I've got the power supply rails. I've got a 12 volt rail, a -12 volt rail. The high threshold 4 needs to be 1.5 volts, and the low threshold 5 needs to be 1 volt. Is already set to 1 volt, so I don't need to change that. Okay, now select this option to solve the problem, number 6. Okay, so you can see that there's a no error, so it's come back with precision values, and I'm going to choose the 1000 ohm and the 47k, which is there. So that's going to be 1000 ohms, 1000, and this one is going to be 47k. Okay, so now that's calculated those two resistors. Now also I need to have a reference voltage. The tool comes back with the voltage that's needed, which is 1.276596 volts. So I need to make a potential divider scale the bandgap voltage from 2.5 volts down to 1.2765 volts. So press the key. Now go back. I'm going to use the E192 series for my potential divider, because I can get it more accurate. So I'm going to change the resistors that I'm using. So 3. I'm going to use the E192 series, which is option 7, and then I'm going to do a potential divider, which is option 8. And the B plus voltage was 2.5 volts, 2, so that needs to be 2.5, and the tap voltage was 1.276596. Okay, now let's see what it comes up with. Okay, so there's 0 error, so that means it's come up with some resistor values which are spot on. And I'm going to choose the 115k and the 120k. Okay, because okay, so I'm going to put in here 15k. And this value here is 120k. Right, so I've chosen values, so I've only got microamps flowing through here. The amount of current flowing through there is going to be 115,000 plus 120,000 is that 235k, so 2.5 divided by 235,000 is, looks like it's about 10 microamps flowing down there. So I want a milliamp flowing through my reference. So 12 volts minus 2.5 volts is 9.5 volts, and then divide that by 0.001 is 9.5k. So what's the nearest resistor value to 9.5k? 9500, and it says to use the E48 series, and the nearest is 9530. Okay, so put in here 9530. Okay, so now I've got all the resistor values calculated for my circuit, which is a inverting comparator circuit, and I will now run the simulator and check that it actually works as required. So I run it, and it's now simulating the circuit. Right, so let's go to look at the results. So the green signal is the signal from the signal generator. The blue signal is the output from the comparator. It's an inverting comparator, so when the signal is higher than the threshold, the output will be low, and when it's lower than the low threshold, it will be high. Okay, now let's just check the values where the lines intersect. So where they intersect is the switching threshold. The switching threshold comes up just down here where the mouse is. Right, so there's one point there, and it's 1.500, so it's absolutely spot on as required. And the other one is there, which is 1.0010, so we're a millivolt out. Okay, so it has worked as required. The component values that the tool suggested were exactly right. There could be a little bit of error because the comparator that's providing the positive feedback isn't at the 12 volts, which you can see here. So this is the high output of the voltage comparator, and it's 11.993 volts. So that's the reason why there is a millivolt of error. Okay, so there you go. This is a circuit that's required for precision switching thresholds. Alright, thank you for your attention, and goodbye.